Security. Security is the foundation upon which our digital lives are built, yet it remains fragile in the face of an ever-evolving landscape of threats. In a world where personal information, financial data, and sensitive communications flow freely across networks, the need for robust protection has never been more urgent. Imagine your network is a busy highway, and every ad, tracker, or suspicious request is a car zooming past, peeking into your business, your browsing habits, shopping quirks, sometimes even personal info. On a typical day, your devices, phones, smart TVs, even fridge, are quietly chatting with countless servers. Some of those are legitimate, like software updates, weather checks, family group chats, but others, they're trackers and ad networks, constantly collecting data on what you buy, what you browse, and who you are. Your smart thermostat or TV might send back usage stats or recommendations, but that data can end up with data brokers who aggregate and sell it. Whenever you visit a site, trackers can fingerprint your device, creating profiles that follow you around the internet. Ever notice an ad for that cool gadget you just Googled? That's the result of cross-site tracking. Some trackers are even more sinister. Malware domains can try and sneak onto your network, exposing you to phishing or drive-by downloads. But are all ads bad? Not really. Ads fund free content, news sites, forums, even mini apps. And some trackers like analytics helps website owners improve user experience. The problem is the lack of transparency. It's hard to know who's collecting your data, how they use it, or even if they secure it properly. Plus, an overload of ads can slow down page loads and clutter your screen. So, how can we balance this? This is Pi-hole, a DNS-level blocker that sits on your network and gently nudges out most ad and tracking domains while letting essential traffic flow naturally. Pi-hole works at the DNS level, or the domain name system. Whenever any device asks, hey, how do I get to example.com? It first checks with Pi-hole. Pi-hole compares that request against its blocklist, collection of known ad tracking and malware domains. And if it's on the list, Pi-hole says nope and returns a blank response. Your device never fetches the ad or tracker. This means that you don't have to install ad blocker extensions on each device because any device using Ethernet or Wi-Fi in your home automatically uses Pi-hole. By blocking thousands of ad domains, page loads get leaner. Pi-hole can also block malicious domains, stopping potential malware the moment they try to resolve DNS. You also have privacy gains because Pi-hole acts as your DNS server. So third-party DNS providers and public ad networks see fewer queries tied to your IP. Of course, Pi-hole isn't perfect. It can't block in-stream ads that come from the same domain as the content, like YouTube ads. Also, it won't catch any apps that are using encrypted DNS unless you configure them to use Pi-hole. So Pi-hole is like your digital bouncer, blocking most unwanted requests before they reach your devices. Now let's turn a Raspberry Pi 3 Model B into that bouncer. Here's what you'll need. A Raspberry Pi 3 Model B. Any Pi works. We're just using the Model B. It also works with Pico 4 and 5. A micro SD card of 16 gigabytes of larger. A power supply of 5 volts. USB works fine. An Ethernet cable. This is optional. And of course, a computer to connect and flash the SD card. First, download the Raspberry Pi imager from the official website. Insert your micro SD card into your computer, open the imager, and select the Raspberry Pi OS Lite 32-bit as the operating system. Choose your SD card and click Write to flash the OS. You can also create a user, set up a password, and connect to your Wi-Fi network by inputting the SSID and password. This will pre-configure your Raspberry Pi so it's ready to connect via SSH. After the installation of the OS has concluded, insert your micro SD card into your Raspberry Pi, connect it to your router via Ethernet, and power it on. To find your Pi's IP address, check your router's connected devices list. You can use an SSH client like Terminal or PuTTY to connect. After you manage to log in, it is important to write sudo apt update and wait for it to update. Then, of course, this is shortly followed by sudo apt full dash upgrade. After you have updated and upgraded your Raspberry Pi, you should reboot it. You simply need to run curl/ssl https install pi-hole.net and then bash. You will be prompted with an installer. Click OK again, and continue. For this example, we would be using VLAN or the Wi-Fi, even though the Ethernet is available, just to demonstrate how a quick setup can be done. If you have an Ethernet cable at your disposal, you can of course use it, but this tutorial is meant to show the minimum requirements to set up Pi-hole. After that, it is important that you choose OpenDNS, then of course include Stephen Black's unified hosts list, and yes, enable the query logging. Of course, we will be going to anonymous mode because we would like to keep all of these ads and trackers away, and of course, it will reboot after finishing its setup. You will now receive all of the information that the installation has been completed. You have the IP of the Raspberry Pi, as well as its web interface, together with its own password. So let's try this out. Now let's see if the dashboard is active. And it seems like it's up and running. Next, it is time to tell our network to use the Pi-hole as its own DNS server. But before we do that, we first must set a static IP on our Raspberry Pi. When the Raspberry Pi connects to the network, it receives an IP, a random IP in the range. Every time that the Raspberry Pi is restarted, it might get another IP. If we want the Pi-hole to scan our network, it must route the DNS server through the same IP every time. So it appears that my static IP didn't work, and the Raspberry Pi changed IP upon being rebooted. So before we can continue, you must set a static IP in your router web interface. For me, this is located under LAN into DHCP server and at the bottom. To do so, you must run two commands, hostname-I to receive the IP address of your Pi, and then nmcli-f general.hwaddr device show VLAN 0. This will output the MAC address of your Raspberry Pi, which is needed for the static IP. So now the correct static IP has been set with the correct MAC address. And for me, in this web interface, I also have the DNS server right up here, so I can set up both immediately. Of course, make sure to apply and save. And once it is completed, make sure to refresh your Pi-hole web interface and check the queries. So there you have it, your own little homegrown ad filter. So now you've seen why ads and trackers can be sometimes useful, sometimes invasive, and how Pi-hole tackles most of those threats at the DNS level. We converted the Raspberry Pi 3 into a privacy guardian, blocking ads, trackers, and some malicious domains without installing anything on our devices. Give it a spin for a week and watch your blocked ad count climb. You can also have access to all of your installed block lists. We only have one because that's the one that came pre-installed. Also, the largest. If you need more granular control, look into client-specific lists or even pairing Pi-hole with a VPN. Protect your privacy, speed up your network, and let the Pi-hole take the heavy lifting off of your devices. So stay curious, join our Discord, and I'll see you in the next vlog. Drive-by downloads.